CP340 Networks and Data Security, Section 9. Contents: Legacy, Legacy Types, Problems with Legacy, Improving Legacy Systems, Networking Issues, and Tools and Techniques, and then references. 9.1 Legacy. A legacy system is an old method, technology, OS, or application that relates to or being a previous or outdated version. These versions of software pave the way to newer versions, such as Windows XP, to today's Windows 10 operating systems. When a system or software is seen to be out of date, it is often referred to as a legacy system. Continued. Even though these legacy systems are out of date, they can still be used heavily, such as Windows 7 being used in a lot of companies since their system could need a massive overhaul to update to a newer OS. So a lot of, let's say for the hospital for instance, let's say they're still using Windows 7, if they update it, a lot of their internal systems that work back and forth could just break. It costs a lot of money and a lot of time to implement newer versions of OS, and often it's not worth it right away, so they kind of push it off. Even if a company moved to a more advanced technology, the effects of a legacy system still linger. Old data can remain in legacy format, which can be fixed using a schema crosswalk, which can be customized to help translate data into a new system. Legacy types. We have end of life. Technologies used by the system are no longer supported. Knowledge. The design of the system is largely a mystery to those who are supporting it. Skills. The skills required to support and extend a system are difficult to find in the market. An example of this would be Cobalt, which is used for banking systems. It's a pretty old programming language that not many, especially people coming into the field, they don't really know, and a lot of the people that worked on it are retiring now. So it's an issue that, like, maybe they'll move to a different language, or they're actually just going to train new employees in this. Like, who knows? Extensibility. The system can't be extended or changed, and the changes would be usually expensive. Types continued. Mean time to repair. When an incident or problem occurs, it takes a long time to repair the system. Scalability. The system is unable to scale to handle anticipated business volumes. Limitations. The system has a limitation such as inability to handle large numbers or future dates. And costs. Recurring costs such as maintenance are high when compared to modern systems. I'm just going to touch on limitations there for a second, because I believe this was an issue for why Windows 8 made the jump to 10, because the code, it wouldn't work with it being called Windows 9 internally in the code. It would break. I think it was due to Windows 95. Problems with legacy. Legacy systems are considered to be problematic by engineers for several reasons. The cost of maintaining these systems may eventually outweigh the cost of replacing the hardware and software. These systems can be hard to maintain, improve, and expand because there is a general lack of understanding of the systems over time, especially with new employees. Legacy systems may have vulnerabilities in older operating systems, or applications due to a lack of security patches being applied. So older exploits on a system could still work, even if like the OS is updated or so on. Problems with legacy is continued. Integration with newer systems may also be difficult because the new software may use completely different methods and technologies. Budget constraints often lead to corporations to not address the need of replacement, and they'll just keep pushing it back, and then it gets more and more of a problem. Most engineers and programmers that maintain these systems are retiring, so younger workers may not be able to deal with older systems, such as the Cobalt example. Improving legacy systems. If it is impossible to replace a legacy system, you can enhance or reface them. This involves adding new infrastructure and interfaces, often via the web, that make it easier to work with old systems in a new GUI design. Printing could be a major issue for legacy systems, so a printer server can be added. Could be adding as an in-between method to change protocols from the old system to work with the new printer and/or systems. So a request comes in, it gets converted to whatever the new system is wanting. Security is also another major issue. One of the solutions for this is to use Telnet or HTTP proxy servers to sit between users and the mainframe to implement secure access to legacy applications. Improving legacy systems continued. A few other ways to make legacy systems work with newer software systems would be to use virtualization, adapters, emulation, and middleman handlers, and interfaces. Most development often goes into adding new interfaces to a legacy system. Networking issues, section 9.2. In the business world, networking issues are extremely common, ranging from simple fixes to more complex solutions to fix issues. These issues could be involving laptops, desktops, printers, servers, firewalls, routers, etc. Dead drop is a common issue where a connected device does not have their connection activated. The switch or router does not show a link light, for instance. Can't get an IP address is another common issue where the network appears down or inoperable. DNS problems are also common, where the client's PC cannot resolve the name of the server with the IP address of that server. Tools and techniques. You could ping. You got tracert or traceroute, ipconfig, nslookup, netstat, putty or teraterm, subnet, speedtest.net for a basic connection check, path ping, and route. Ping, I would say, is probably the most common. You just ping, if you're trying to diagnose your network problem, you just ping Google, for instance. That's a pretty simple one. References, where I found my information. And this concludes section 9.